Yeah, I'm just going to take a little time here to talk about my black copper oxide coating I use for my selective absorber on the solar trough water heater. Now, this is not my water heater trough. It's just a picture I found. Um, the interesting thing about this one, which is not mine again, this revolves around the tube that's used for collecting the heat. And I did not want to go that route. I would have been a little bit bigger. But I put this picture here because on the next picture you're going to see that mine doesn't quite look like this at all. Um, in fact, this is it right here. And this is about 13 feet long end to end. And I'm not having the metal or the parabolic trough. You can see I have one strip of mirrors here. I'm using just flat mirror, kind of, it's encapsulated in silicone and waterproof, but I only have one of them up there too. I was not going to work on the plumbing of all these lights and everything, and it's going to make it easy for me to do. And probably the mirrors will be the last thing I put on here too. But what this is the augment this PV system here. Now I'm real happy with how the PV is doing. If I get 3 days in a row, it's triggering the solid state relay, turning it off. But I know it's only on the top third of my water heater. And a water heater tank I got actually has a heat exchanger coil in the bottom. And that's what I'm trying to do here on this one here too. And I went this route. I mean, I thought about different ways. I really like the encapsulated tubes. I think they're really cool technology. I can't turn them off though once they're going. And some of the simpler systems too with the well, just a box of PVC or a box of PEX line might work fine. But this gives me more control because with this system, I can simply take it out of focus if I get too hot. So this is it's a lot of fun to make too so far here too. And the project has gotten so big though. I'll be covering it in stages. I mean, today I'm talking about the selective sorber coating on the target pipe. But I'll go ahead and talk about the tracking system. Here's the little tracker right here. Usually I have a mason jar around that. I just took it off here so you can see a little bit better here too. And I'll talk about the plumbing, electronics all later on. But today, it's really just more of this, how this thing works. And again, mine has the axis on the bottom down here. And I'm using these Mosmatic Rotary unions, they're called. In fact, I've got the axis of the rotary union, the same axis of all my bearings, so they all move together in one piece then too. And this allowed me to make a much smaller system. If I was going to make a system that had the axis on the top up here, well, it'd be revolving up and down in the wintertime and blocking a lot of my PV, and that would take a lot bigger structure. This one I could make it a lot lighter then too. So this is why I'm going here too. I started this last year, but we had such an early winter that I just like had to stop, and so I'm starting again, getting this thing done. In fact, um, what I got this year, I went ahead. This is the secondary mirror at the top up here. This is just made of aluminum flashing with some L aluminum on the end here too. And right now I just got it clamped on here, but you can see on the reflecting here too. This is the black oxide coating I put on all the pipes here too. And you can see with that one mirror right now, it's all I got on here and reflecting on that. And even though it looks like a different color, that's just because the light is hitting it too. And interesting enough, with just one mirror, I can put my hand on that. It's not hot, but it's definitely warm to the touch, which is kind of surprising then too. So, and the reason I want this, the oxide coating is good, selective absorber. Unfortunately, it's not as durable. Although if I scratch it, yeah, I can scratch right through it. But I can scratch right through paint too and take it right to copper. So that's what this top reflector is for. It's hopefully will decrease some of the convection from the wind, as well as actually it's all shiny aluminum, so it's going to rebounce it back to the top then too. So this is actually a video of showing a little bit of the movement of the tracking. It just sort of continuously looks at it, and if it's happy, it sits there for 4 or 5 seconds and moves on, and looks at it again then too. So, but that's the motion and movement here too. So I'm using 1/2 inch my line. I'll talk about all the plumbing later on here too. And really, I want to just try to get focusing only on the coating I'm using here too. So um, now, just to get everybody up to running on speed here too, a selective absorber is something that actually will suck up the heat like a flat black object, but it'll radiate it like a really shiny object. Okay, and I got into it years ago the wrong way. I was trying to do some flat plate collectors using a selective absorber, and I did some reading, and they said, "Oh yeah, graphite paint was one," and I have not found that to be true. Um, but technically, a solar thermal collector, a selective surface, or a selective absorber is a way of increasing your efficiency. It gets a higher temperature of your target because it doesn't radiate things away then too. In fact, down here in the bottom, and I tried to get the references to this. It's University of Mississippi, but the reference link was broke. But on flat black paint, yeah, I mean, they say a perfect absorber is a perfect radiator. And you can see down here, yeah, flat black does a great job absorbing radiation, but it also lets it radiates it right away here too. Whereas in copper, treated with this black oxide, it absorbs very, very well, but doesn't radiate very well away. Okay, so it's actually a much more efficient way of doing this. My brother-in-law, unfortunately, found out this the wrong way. He had a real shiny object. He had a crescent wrench outside working on his tractor, and he set that crescent wrench up on a dark fender, brand new crescent wrench or something shiny, and he let that thing sit there for a while, and then he picked it up, and of course, just about he had to drop it. It was burning his hand. And what that does, of course, if it's sitting on something dark colored, well, you're going to get that convection. You're going to transfer the heat to it, but that shiny object will not radiate the heat away. Okay, so that's what we want here too. You want something that absorbs like black, but will not radiate away. If it doesn't radiate away, the heat just goes up just like that wrench did. Okay, so now I am a little hesitant to talk about some of these things. Where it says use extreme caution, I will not be held responsible for anything here. This is just FYI for your own information here too. I'm using sodium chlorite, not chloride, chlorite, ITE. And again, this stuff can be even explosive if mixed with grease. It's got nothing but bad things about it basically here too. So use with extreme caution. Okay, it's quite an oxidizer. Um, you've got to be real careful how breathing, mixing, everything here with this particular stuff. Sodium chloride, okay, that's the first ingredient I used, and the next one's no better anyway. That's actually sodium hydroxide or just plain lye. Um, it's amazing what you can buy on Amazon. Both these things were just shipped to me here too, but caustic soda here too. Um, Again, very caustic. It's the opposite way of an acid, except it's worse. It will just melt fat and burn you, and just nasty, nasty stuff here too. So you have been warned here. But those are the two things I mixed together with distilled water to make this bath solution where I'm actually blackening copper. Okay. Again, I'm providing information without any guarantees of being correct. Use it in your own discretion. I take no responsibility. I'm barely responsible anyway. So anyway, but I found this in a book that talked about making selective absorbers for solar collectors. This is something they're using in Australia. And I found 2 or 3 different references too, but this is what I used. Per liter of distilled water, I put 100 grams of sodium hydroxide and 50 grams of sodium chloride. Okay. Now add the sodium hydroxide to the water. It's exothermic. If you would just put water into the sodium hydroxide, you're probably going to get a steam explosion. Could be. In fact, I put the dry ingredients into the water in both these things here too. So, and all mixing equipment, stirring, whatever you're cooking it in, all this stuff has got to be just squeaky clean. I actually used all sorts of cleaning degreasers, distilled water, and cleaned everything up as possibly as I could here too. I also got a system going with the great ventilation. I kind of almost made my own lab hood, the way I use my shop here too. And you need personal protection equipment. That's the first thing I got, and that's the first thing you have to do. Anyway, after you get this all mixed up, what I did, I made this little tube, and I'll talk about this, how I cooked it and everything here too. The blackening bath temperature was 210 to 215 degrees, okay? And treatment time is 5 to 10 minutes. The first one I put in there wasn't quite up to temperature, and it took a little bit longer here too. And the last one certainly did it in that time period. although I was getting a small steam explosion every now and then bubbling out. So again, be warned. So this is the first thing you got to get. Here's my Breaking Bad look, I guess, here too. But organic respirator, chlorine gas, type of stuff. You've got to have this so good, tight fitting respirator, face shield, PVC forearm sleeves. These things right here in case you spill out here too. These are not the inspection medical gloves. These are the laboratory thick chemical resistant gloves here too. PVC apron. I got big boots on down below, resistant too. So yeah, this is the first step. What you got to do to get this stuff down here too. And I wish I would have had more pictures taken when I was doing this, but I was just handling it. I had stuff on my hands, and I figured, well, the pictures I'll just have to talk about. I won't be able to take pictures of that time then too. So, but this is the rig. This is what I set up in too, and you can see here, this is a steel pipe. Now, the percentage of these oxidizers I'm using will make steel brittle. Okay, stainless steel brittle. Now, but of course, it'll take time to do that. So I'm using this black iron steel pipe. It's 5 feet long, inch and a half diameter. I kept it pretty thin. That way, I would not need a whole lot of the bath material then too. And I used a camp stove down here. And yes, this is an aluminum pot. Aluminum and sodium hydroxide are not compatible. In fact, what it'll do, it'll wear eat it up pretty quickly and generate hydrogen gas, and you've got to be kind of careful here too. In fact, you can see this is one of my mistakes I used. I have this aluminized mylar plastic. I put on it the tube here, just to kind of keep insulation going. It was hard. I was having a hard time getting this whole tube to the required temperature here too. So I'd wrap the whole tube up, and basically a couple times even though I had some headspace at the top, it would still bubble up occasionally and dribble back down, and it almost immediately stripped the aluminum off this plastic, which means it generated a lot of hydrogen gas when that happened. Now, what you don't see in this picture, right above this tube, right above this area here, I have a 3-foot square opening in my shop out here, and on the other side I have the garage door open a little bit, and I actually have a wood burning stove on the other side heating the whole place up. So what I did, I took that panel off the ceiling, and all the air was just rushing up from this area. Like I said, camp stove, open fire, lovely chemicals in the air here too. All these things going up in my attic, which in my roof vents basically were just taking care of it out into the world then too. So you do not use PVC. It's way beyond the temperatures for safe PVC, and this concentration of sodium hydroxide in water is going to be deteriorating anyway. I decided I could have used copper, but it would actually use a lot of chemical reaction inside the copper tubing itself. And of course, do not use aluminum. It will eat it up, and basically, no, don't do that. That's how they used to generate hydrogen gas for blimps and things then too. So, but this is my system. I have the pipes up here. You can see the residual chemicals that have boiled over. I had everything secured here, so it could not be knocked over during the cooking process. Now, what I used down here in the pan was antifreeze. Okay, antifreeze. I know they put sodium hydroxide into antifreeze to adjust the pH, so I know they're compatible. And I could not generate enough heat with just using water because that boils at 212 degrees. So I put antifreeze down in there to get a higher temperature than that too. So, and sure enough, I could get above that temperature I needed then too. And it still took a long time to get the whole tube up at that temperature too. So, but during the heating stage, I was using a propane torch even, just heating it on the metal and trying to get the whole thing hot. Now, what's not pictured here too, I had a couple temperature sensors on here that actually tell me, I had them wrapped up on the outside of the pipe, and they would tell me kind of what I'm doing on the temperature all the time too. So, but I mean, yeah, it was a little bit of a hassle to get set up, and it's really the only DIY selective absorber that I think I can do. In a shop. I know they have black chrome and things, but it looks like electroplating and everything else. And I figured, and I was there. I know there's a spray can of stuff, Thermal Max or something, and I'll talk about that in a little bit too. But I've seen some demonstrations that didn't work very well, so I figured I'd go this route and see how it works. And I'm really happy how it's turned out. I've even done some testing on it here too. So I put this on top of the boiling or very hot antifreeze just as a kind of an insulation thing, and you can certainly see areas that got splashed on. I was doing really good until the very final pipe, and I started really getting a lot of bubbling and bubbling up the top, and it was kind of Vesuvius every now and then with a little bit of a bubble up. And even though I had like a 6-inch headspace, it still was not enough at times. It would bubble over here too. So, because what I do here, what you don't see here, I had to cap off that pipe here too, and I put a pulley up in my attic space, and I actually used a rope to lower the copper pipe down into it. And that way I could raise it up and lower it down as necessary then too. But usually it was resting in the bottom of the pan. And I did have it sealed off. I decided not to put the black coating on the inside. I treated my pipes differently. Actually, I used a long rod and a screw gun to abrade the internal parts of the heat exchanger or my copper, three-quarter inch copper then too. They said if you can get some disruptions like that inside, it really kind of turbulence helps the efficiency of heat transfer then too. So, but that's what I did, trying to be as safe as I possibly can here too. Um, like I said, everything was really cleaned up the best I possibly could before I started this. It's a mess right now because of the way it bubbled over here too. So, but this is what I had, and I have to say the whole thing was accomplished in one tank of white gas for my stove. This is kind of my secondary stove. I figured if it goes up, it goes up. I can get rid of it, and I have a fire extinguisher, by the way, really close to this whole area here too. So I tried to be careful as I possibly could. I had to do it inside though. I just couldn't think I could keep the generating that heat outside. It was just, a little bit of wind taking things away, and I thought, no, it's got to be inside for my control and to secure it in a place that I actually have some control with the pulley and everything. So this is what I did, and this is actually what I was after. This is the black copper oxide coating. Um, it makes these little nanoparticles, and it looks like velvet. And this is the cut off pieces. I knew I could not do a 13-foot piece in one go here. So what I did actually 4 pieces of using 3 of them. One was just kind of a backup, but I had sealed up one end of the copper. Just let it solder it together here too. The other end I actually drilled a hole in it, had a wire in it heading to my rope with the pulley on the top then too. And this is the cutoffs, okay? And I know it says it's not the best when it comes to durability, but even down here where you can see I used my cutoff wheel pipe cutter, it actually rolled it down, but it did not scratch through it. I think this is going to last a long time. I'm hoping anyway. So, but again, a 60-inch, what I had here, 1-inch pipe, and it was easy to figure out how much solution I needed, because what I did when I had the whole thing clean, all pipes clean and everything, I put the copper pipe in there with just water, and of course it just spilled over the top, displaced what I needed, and then I pulled it up again and measured how much water I had. And that way I knew how much material I needed to make, and really making a liter is all I needed. Even then I didn't use all of that, so it made it really simple then too. So um, all these end pieces here too, I'd already had my elbows on the pieces done on the end pieces. The middle piece, that was just the one that I drilled a hole in here, but both my end pieces actually already had all the soldering done, all that here as well. So that made it easy. I did have to cut it to length and solder the rest of it here too to the down rods here too. Of course, I'll put these little threaded unions on here too. That way I can repair it if necessary or need to replace it or something here too. So anyway, okay. Now this is how I tested it. I saw one of these online. Someone had done this test with Thermomax stuff and some flat black paint, and a Thermomax, if that's the spray can, if I'm remembering it right, did not do very well. He had it in a box, and the flat black paint had beat it every time. And so I figured, well, a while ago I replicated that. And what I did, these bigger squares here, this is graphite paint. And this is the barbecue flat black paint. And what I did, I taped on my temperature sensors on the back of each one of these pieces here. I put them in a box. Had some glazing on the front, and I was like, wow, the graphite paint was so much better in this first run through. And I thought, oh, this is it. I read about this correctly years ago, and I thought, well, fantastic. And then to be sure on the validity, I went ahead and switched them around. I switched both the sensors, I switched the positions, and everywhere I went, the flat black paint beat the graphite paint. Okay, so I figured, well, yeah, proof thing. Show me the proof. Show me the research, I guess, then too. So I did not take a video of those days when I did that then too. So, but what these two smaller ones are here in the middle, this stuff looks like the velvet. Well, that's that black copper oxide. Okay, now what this is, I'd gotten some real thin pieces of PVC, and I mean thin. They were copper coated one side, too thin, almost too flexible for me to use. So I decided not to use them for my project I was working on. But it was perfect for these things, nice and lightweight. And so I cut two identical pieces, handle them the same way. Tried to get the same amount of paint. It's hard to do, but anyway. This is the flat black one, and this is the black copper oxide. And again, I tried these in different positionings and all that too. And by this time, my two sensors had gone bad. Okay, I only had one thermometer anymore. And so instead of actually doing that, I went out and used my infrared thermometer. Now, when I was doing this, I was just going back and forth fairly quickly. And again, I tried different positionings. I moved the pieces back and forth. In case the wind, convection, whatever might be influencing or something here too. And every place I put the copper oxide, it was hotter on the back, okay, versus the just flat black. And about 10 degrees hotter. It was like, wow, that was pretty cool. And no matter where I put it, it beat the aluminum, it beat everything, okay. And what really made my mind up here too is that when I went to the front, okay, well, these things don't radiate, remember. That's the what's the absorber, selective absorber. They will absorb, but they won't radiate. And so I went back to the front and started shooting the front of these things, and sure enough, the flat black on aluminum here was 73, and however, 64 was the copper oxide. That's when I started thinking this is really a good stuff and a good way to go and do that then too. So. But anyway, I'm kind of happy how well this has turned out. So I will be posting the rest of these things when it comes to finishing the rest of this. I still got some mirrors to make here too, and I'm got a little bit of plumbing to do. I'm actually using PEX Al PEX running inside here too. My maximum temperature, I'm shooting for about 150 degrees. If I get 150, whatever, that's going to make my water heater just perfectly fine. If you want to see what I'm doing on the water heater side, go back and look at my PV heating using my water heater too. I will, as I get a little bit further along, post more, like I said, on electronics. The software I got for this too. I'm using an Arduino Mega, which I made a shield for. And I am measuring the temperature in and I'm measuring the temperature out. Same with the tank in and out. I'm measuring the pressure on the line. Of course, I'm measuring the light intensity up and down here too. So I have a lot of sensors built into this, so I can really control it how much I want it to move back and forth necessary then too. So what I have here, just briefly on my little sensor box here, not only does it measure the light levels for up and down, which way it moves, but it also has tilt switches built inside of it. That way it will go so far. Only go so far, and even though I can move it without the entire range of my linear actuator here too, the tilt switches will trigger it long before that too. So anyway, I'll try to keep you posted here too. It's kind of a rainy day. It's figured it's going to be a nice day to kind of start with this thing here too. So, but been kind of a fun project. I'm kind of waiting to see the end of it, but anyway, hope this helps. And remember, dangerous, horrible burns with these chemicals. So you have been warned.